In this section we are going to discuss how curved poly models are tessellated in a fair amount of real polygons. One thing we like to do when we are working on tessellations is to activate some wireframe on the model. This is easily done in the last versions of Unity by either activating the selection wire option in the gizmos menu of your scene, or the shaded wireframe mode and shading mode menu. Curved poly tessellation algorithms are based on a levels of detail table which can be customized. Such table is stored in the project with a specific asset called LoDs. You can find the default settings for the LoDs table at asset/curvedpoly/LoDs/LoDs. If you open the asset, it should look like this. Each LoD is a record in the table and you can add how much LoDs you wish with the Add LoD button. On each LoD you will find a set of 16 integer values from hint A to hint P, where each hint contains the amount of segments an edge should be tessellated with. So the basic of tessellation algorithms here is that you can freely assign hints to your edges, and then you can switch LoDs on the model to achieve different results. Usually hint A stays for a very low resolution and hint P stays for an extremely high resolution, but it's pretty much up to you. Each LoDs is used to tessellate each edge in a different way, according to its hints assignment. We are going to see later how hints are assigned to edges in depth. By default, you will find 6 clearly understandable LoDs named close, near, normal, distant, far, and box. Their values have been set up to be consistent with our tessellation algorithms. That said, for practical situations you will probably choose to use the default settings and limit the use of LoDs only to a few values, perhaps near, normal, far, which is a fair enough choice. Also, we often use close during editing, because we like to see our models at maximum resolution while we make them. If you want to edit LoDs records, there are a lot of things you can do here. You can create your own custom LoDs asset in the project panel pop-up menu or with the assets menu selecting create then curved poly then LoDs, if you wish, or change the default one. Once in the LoDs asset inspector, you can add new LoDs with the Add LoD button. Pressing more times the Add LoD will automatically create a series of incremental LoDs values, which may be a good starting point. You can also clone a record you have already assigned with clone buttons, and you can remove the LoDs you don't need anymore. And you can give each LoD a name which fits with your intentions. While editing a LoDs asset, keep in mind that you are free to have how much LoDs you wish, since this is a very small asset, but if you use a LoDs table in play mode, you should try to use a little amount of them. You could even have a different LoDs asset on each model you create if you wish, but it's preferable to have only one or a few of them shared among all your models, especially if you use curved poly in play mode. Also, we suggest that you avoid changing the LoD table frequently while editing, as there are some tools that rely on LoD assignment and can give strange results when LoDs are changed. Below the table records you will also find helpful hint views, which contain the same data rearranged by hint, the table column, and not by LoD, the table row. By the way, for the purposes of this section, we are going to use the default LoDs. When you have a LoDs asset, either the default one or a custom one, you can assign it on your curved poly component. The choice above the LoDs asset will be automatically updated with the list of all available LoDs. Each time you change the LoD, your mesh will be recalculated with the alternative tessellation values. If you need to check the impact of editing on more levels of details at once, you should use the LoDs preview window. This can be opened from the curved poly component. Once this window is open, it will show changes happening on your models at different resolutions. You will also see an overview of the total amount of vertices and triangles used by each version of the model. Keep in mind that this mechanic is available both in edit mode and in play mode, as it is part of the curved poly runtime. Within the curved poly package, you should also find 2 demos showing how to take advantage of tessellation at runtime. The first demo shows how to change the tessellation amount on models at runtime. The second shows how to take advantage of the LoD component in Unity, in order to change the resolution of your models dynamically. So, curved poly's tessellation is all about determining how much segments should be used to tessellate each curved edge. Then, the filling algorithm on each polygon will do the rest. As we have seen, the exact amount of segments is determined by a level of details, and by the hints assigned to each edge. When tessellation tools are active, curved poly will show tessellation hints on all selected edges. Then, you can use any of the selection mode we have previously covered to select the edges you want to change the hints on. On each edge there are 2 hints, one for each side of the edge. If you assign the same hints on both the side of the edge, curved poly will tessellate that edge with the exact amount of segments which are assigned in the LoDs table. If the hints are not the same, Curved poly computes a continuous gradient of segments, where the segments are smaller where the hint is high, and larger where the hint is low. Once a group of edges has been selected, you can also change the hints on all them at once, using the tessellation hints buttons. For example, we can try to switch all the edges to tessellation hint A, to see if the lowest resolution possible is acceptable on our model, or on parts of it. Above this buttons we have a choice to change the LoD assigned to the model, which is synchronized with the one you have in curved poly component. On this one, the time it takes to recalculate the model is also shown. As you can see, it is quite fast. On some models you may have parts which does not require to change when the level of details is switched. If that is the case, it is possible to freeze one or more edges to one specific LoDs, by pressing on Use Fixed Tessellation. The edges marked with fixed tessellation don't change anymore when the tessellation is changed. If you want to change the tessellation amount, you can select again the exact same edges, change the level of detail to the one you want to use, and press again Use Fixed Tessellation. And when you want to make the edge answer again to level of detail changes, you can press on Use Runtime Tessellation, to move them back to a tessellation which answers to LoDs change. One last thing. For a complete interaction with the model, we have added to Tessellation Tools a control over polygons filling algorithms, not different from the one used in Shape Tools. With this control you can correct potential issues generated on polygons after the change is made to hints and level of details, and also try different combination of filling algorithms with tessellation data, in case you need to lower the computation time of tessellation.